Alrighty. Today we're talking about parallel and perpendicular lines. In order to understand and tackle a few problems that we're going to talk about, like corresponding angles and all that fun stuff, we need to know the definition of perpendicular and parallel line. So, parallel lines, okay, are lines that will never intersect, and they're coplanar. So remember coplanar, same, planar, plane, same plane. Usually to indicate that lines are parallel, we'll see an extra little arrow going the same way. Perpendicular lines. Those are lines that are going to intersect and form a 90-degree angle. So two lines intersecting, and if they form 90 degrees, then they're perpendicular. Skew lines. All right. Skew lines are lines that never intersect, but they're non-coplanar. So non, not, co, same, planar, plane. So they're not on the same plane, but they don't intersect. So for example, I got my little cube here. Okay. So, I can draw a line here. So parallel lines, these are on the same plane and they're not intersecting, but these aren't skew lines. So I need to find a line that's not on the same plane. So for example, so these lines, hey, they're not intersecting, but they're also not on the same plane because they're skewed. So this is an example of skew lines. Okay, let's talk about parallel planes. Same concept as parallel lines, but guess what? We're not dealing with lines, we're dealing with planes. So if we look at our cube here, for example, remember a plane kind of looks like a parallelogram. So if I were to find a plane that's parallel with, let's call them plane K. Right, just trying to find another plane that won't intersect with this guy. So another plane that would not intersect with plane K would be this bottom one right here. So I'm going to shade that in so it's a little bit easier to see. So you can see that we have two planes, like two parallelograms, that are not going to intersect. So now let's talk about transversals. Transversal is a line that intersects with two or more lines that are coplanar, and they'll intersect at different points. So for example, looks like I have two parallel lines right here. Okay? But I have another line intersecting with those two lines. That is this guy right here that's intersecting is a transversal line. Now let's look some more at this guy and the different angles around him. OMG. Okay, so let's talk about corresponding angles, right? So corresponding angles are just angles that are on the same side as the transversal and also the two lines that we see. Now if the lines are parallel, the corresponding lines, not lines, but angles, will be congruent. If the two lines are parallel. Feels like, hey, which angles are corresponding angles? Let's think about it, okay? So they have to be on the same side as the transversal and also with these two lines. So for example, this is like angle 6 and angle 2, kind of like the same. They're on the same side as the transversal and also on the same side of the two other lines, okay? So angle 2 and angle 6 are corresponding angles. Let's see if there are any more. All right, what about maybe angle 1 and angle 5? Okay, they're on the same side as the transversal and also on the same side of the two lines. So angle 1 and angle 5 are also corresponding angles. I bet you can find some more, and I'll make sure to put a list of the rest. Okay, alternative interior angles. Let's see if we can find some. All right, so what those are angles that are going to be on the inside of the two lines, but they're going to be on the opposite side of the transversal. Now, once again, if these two lines are parallel, then the alternative interior angles are going to be congruent. So let's just pick one that's on the inside of this guy right here. So let's try angle 5. Can we find another angle that's on the inside, but on the opposite side of the transversal? I think I found one. Angle 4. Okay, so angle 4 and angle 5 are alternative interior angles. Do we see another one? I do. Okay, so let's see, angle 3. Right, think angle 6. It's on the opposite side, and it's on the inside of the two lines, right? So angle 3 and angle 6 are also interior angles. Now, we talked about interior. What's the opposite of interior? External. So we talked about interior. Now let's talk about the opposite, exterior. Okay, exterior is the same definition as the last one, okay? But instead of saying on the inside, it's going to be on the outside. So we're trying to find angles that are on the outside of the two lines, but they're going to be on the opposite side of the transversal. Struggle with that. That's okay. So I'm looking for two angles that are on the outside. Okay? So let's just try 7, because I know it's on the outside of the two lines. Okay? Okay, so if I have angle 7, okay. Now I need to try to find one that's on the outside of the two angles, but on the opposite side of the transversal. I think angle 2 would be, is match. All right, let's try to find another one. Okay. So let's look at angle 1. Okay. Go ahead and try to find one on your own. Right, did you get angle 8? These are both on the outside, and they're on the opposite of the transversal. Let's talk about consecutive interior angles. So if we were to look at this guy right here, if we were trying to find angles that are consecutive interior angles, we're going to stay on the same side as the transversal and look at angles that are in between these two lines right here. Okay, so let's look at angle 3. Okay, so the other pair would be what? Angle 5. So those would be consecutive internal angles. Let's try to find another pair. Okay, what about angle 4? What's its other match? If I'm looking for consecutive internal angles, angle 6. Boom. So you notice with these pairs of consecutive internal angles, if you add these together, they would be supplementary angles. What? If you have any questions or confused about anything, please refer back to this video. I will have it on Schoology for your use to help you.